Hey there folks, welcome to Learning Labs. Today we're talking about all about graphing. Graphing. In grade 6 math, there are three main types of graphing. You have a dot graph. A dot graph graphs discrete data. Okay? That is countable in whole numbers. Whole numbers. For example, helmets. Okay? Helmets sold. You can't sell half a helmet, or hope you would not sell half a helmet. You have to sell a whole one helmet. Okay? So when you're doing a dot graph, you want to only graph data that is in whole numbers. Another example is humans, counting population. Okay? You can't have half a human. They're dead. Number 2, line graphs. Okay, that's the opposite of dot graphs. Continuous data. That's what we're graphing. So numbers that have numbers in between numbers. Okay, numbers in between values. So that could be like temperature. All right, there's 25 degrees, there's 26 degrees. There's also 25.5 degrees. There's also 25.555 degrees. Okay, there's numbers, there's values in between those numbers. Finally, we have bar graphs. This is slightly different. This is comparing counts of different types of things. So maybe we're counting sales of helmets as well as stickers and candy. Each one would have its own bar, and we can compare which one sold the most. Let's do a couple examples to help you with this one. So example 1, helmets sold. Okay, here on our data table, we have a left and right column. Left is showing us time, so January, February, March. And on the right here, we have helmets sold, number of helmets sold. January sold 3, February 5, and March 10. We can graph said data. We can graph said data on our graphing paper. 1, we're gonna change 1 into January. It will represent January's data. January had 3 helmets sold, right here. Okay? Now, I think I got ahead of myself a little bit. We should label our axes. Let's label here. This is our y-axis. So on our y-axis, we're gonna have number of helmets sold. Okay, that's our y-axis. On our x-axis, we'll have the months, so we'll have time. Okay, so instead of 1 we have January, instead of 2 we have February, instead of 3 we have March. Okay. Okay, now that our axes are labeled, we can continue to graph our data. So January, 3 helmets sold. February had 5 helmets sold. So we find February, go all the way up to 5 for our value, and there we go. March had 4. Find March, find 4. There we are. So our dot graph is complete. Points are plotted, axes labeled. We can even give this whole graph a title here. We'll say number of helmets sold per month. I would even include the year there if the year was provided in our data table. Okay, onto a line graph. Graphing continuous data. Okay, here's our data table. It is looking at time versus temperature. Okay, now it's pretty cold out here. So at 8 a.m. this morning, it was 0 degrees. Again, I got ahead of myself. Let's label our axes. Down here, I'm gonna do time. Okay, we're gonna do 8 a.m. right here. Number 2 is gonna be 10 a.m. And number 3 is going to be 12 p.m. Okay, noon. Right, over here we're gonna do temperatures. Make sure we do our units, so Celsius in Canada here. Okay. And 1, 2, 3, 4, 5 is fine. Let's begin. So 8 a.m., 0 degrees. Here's 8 a.m. Where's 0? 0 is right here, it's invisible, so it stays on the axis. 10 a.m., 3 degrees. Let's find 3. There he is. Boom. Finally, we got 12 p.m. is 5 degrees. There we go. Now, it's a line graph because temperature is a continuous data form, okay? From 0 degrees to 3 degrees, it didn't just jump temperatures, okay? Outside, it's not all of a sudden it's 8 a.m., okay, it's 9:55, 9:59, and now we're at 10, all of a sudden it's 3 degrees. No, it actually grew in temperature, okay? The temperature went up slowly over time, okay? There was values in between. At one point, it was 1 degree and a bit, okay? Then it was 2 degrees, then it was 2.1 degrees, then it was 2.9, then it was 3 degrees. There are values in between, very key there. And then from 10 a.m. to 12, it grew even more, okay? What does this graph tell us? Well, we conclude from the data table, the line is going up as time moves forward. That means as time moves forward, it gets hotter and hotter, okay? Which is our graph. Okay, now we have our data table. Goat shop sales. Items sold, granola bars, candy, stickers, numbers sold, 2, 3, and 5. Okay, so the goat shop is a shop I run every Friday for the students to spend their in-class currency on a little bit of treats. So let's begin. How do we start? We start by labeling our axis. Finally, I learned something. Let's go x-axis. Let's get our items here. Okay, item number 1, G-bars. We're gonna go GP for short. Okay, number 2 is candy. And number 3, we got stickers. I'm gonna write ST for stickers. Okay, label your axis, which would be items. Okay, over here we have our numbers. Numbers are fine. We have numbers sold. Okay, that's counting how many are sold. Okay, since we're comparing different things with different values, we use a bar graph. We're gonna compare our sales. Which one sold the most? Let's find out. Okay, granola bars sold 2. Find 2, right up there. Boom. I'm gonna color code these ones. Granola bar sold 2. That's our bar. Candy. Candy sold 3. Let's go find 3. There he is. Excellent. Don't mind my non-straight lines. Finally, we got stickers at 5. Here's stickers. Here's 5. We are good to go. Do a little color action. Check it out. What can we conclude from this graph? Well, since it's goat shop sales and we're looking at items sold and number of sold, we can see that stickers outsold our both granola bars and candies. Okay, so that means as the goat shop manager, I should probably look into buying more stickers because they sell so hot. They're a hot commodity. Granola bars, I probably bought the wrong flavor. Kids don't like it too much. So as a business manager, to increase my sales, I'll either buy more stickers or buy a different granola ball style. Maybe chocolate. Everybody likes chocolate.